So without further ado, Merlin Morey presenting on Python for security automation and response.
Thank you. Hello. I do need one more second. I have to push the button for the notes. All right. So welcome to Python for security automation, orchestration, and response. This is brought to you by Merlin. I am the great wizard Merlin, and it looks like we're all ready to begin finally. So let's do it. Move this over here for ease of use. There we go. All right. So security orchestration, automation, and response can greatly improve both the speed and reliability of security incident response. That's the basic value proposition. I'm going to say that you probably spend way too much time manually repeating the same tasks over and over again, and I'm here to convince you that instead you should spend way too much time automating things. And you're going to spend a lot of time doing things either way, but it's way more fun to automate than to do the stuff manually. So me personally, I'm an experienced security analyst and engineer. I spent a lot of time automating various processes and workflows to improve security information, security operations, simply because I enjoy automation, especially if it improves the lives of my team or especially myself. And I often will automate in anger, as in if something pisses me off, makes me upset, that's what I'm targeting to fix next. So you're here, hopefully, to learn about Python for security orchestration, automation, and response. So ideally, to get the most out of this, I'm assuming that you are yourself a security analyst or engineer, or maybe you are a Python programmer or software engineer or student, or maybe you're even a manager who manages people doing these things, and you just kind of want to learn about SOAR and how Python can fit into that. And if you're here for some other reason, then that's great too. I'll be happy to talk to you for the next hour or so. So in general, Python has a lot to offer security analysts and engineers. Python is known as a batteries included language. So there's a lot of utility that comes built in it, which you can use in any environment. So for example, built within base core Python, you have crypto libraries, HTTP libraries, just all the basic stuff that you need to interact with things on the internet and do work without having to install any libraries. So that means if your organization allows a Linux or Windows machine to have Python installed, you can use it. We'll come back to that. Additionally, third-party Python packages offer a whole lot of power, especially if you can install them in your environment, which that is, of course, the sticking point there. So generally, we've got all kinds of famous libraries you may have heard of, like Requests is the famous Python library for handling HTTP requests in a very elegant and easy way. There's a library that I like to use called Beautiful Soup, which is very good at taking apart XML, HTML, etc., so that you can get the data that you need out of arbitrary web pages. And then you can get into like the whole data science realm of things like NumPy and Pandas. A lot of security tools generate tabular or CSV type data, and data science tools such as Pandas are written in C but expose a Python interface, which gives you a very efficient means to process, say, a CSV with 500 columns and 1 million lines, right? Like that's the kind of stuff that we're talking about processing in this realm. And in addition to that, there are, of course, a bevy of third-party libraries that are essentially an API wrapper for an external service. Say like, if you're familiar with AWS and their S3 storage service, there is a Python library called Boto, which will let you interact with S3 from a Python script. And just like that, for that service, there's similar clients for basically any service under the sun that you can think of. So basically, Python is the glue language of our time, essentially. It lets you interact with any ecosystem to pull data in and out and transfer it around. And that's kind of why we're looking at Python specifically here. So SOAR is the industry acronym for Security, Orchestration, Automation, and Response. This is a flying snake, and apparently it can glide as much as 100 meters through the air with directional control by slithering in the air, and that beats all other flying animals, including a flying squirrel. So my metaphor on that is security teams with SOAR tools and Python skills, they're the ones who are flying above the treetops while everyone else is slithering through the underbrush and getting hurt by all that pain. I'm going to go even further and say that if you invest your team's time, effort, and budget into SOAR tooling, that can allow you to truly fly, just like this majestic beast here that some of you may recognize. So in more general IT terms, you may have heard of like DevOps or just in general IT automation, and that improves both the speed and reliability of those processes for delivering services through automation. DevOps generally focused on, say, the release of a product, like your latest version of your website, and how it gets from the dev code out. There's a whole lot of automation involved in that these days because it saves time, reduces errors. Just like that, that's what SOAR essentially is for the security organization. It allows you to automate and make reliable these processes and workflows that you have to repeat over and over again. There's also a new term coming out now called hyperautomation. I don't know if any of you have heard of that, but hyperautomation is where you go across all business units, so not just DevOps, not just IT, not just security, but your entire organization. And you leverage AI tooling and machine learning, et cetera, so that you can create automations that react to the entire business. And then you take it a step further now in 2024, and you automate the creation of those automations. That is what hyper automation is. So that's kind of the, to me, higher level thing above, you know, SOAR, DevOps, which are kind of like siblings of each other. I do want to caution, though, that care is needed when you embark on ambitious automation projects, because they can fail in all of the ways that other projects do, such as costing more in terms of implementation and maintenance than they actually save. So you want to make sure you do enough research up front that, you know, the time spent to automate and maintain your automation is actually going to be cheaper than manually doing whatever process we're talking about automating. Additionally, you want to make sure you're automating the right things, because you could solve a problem that you think you see as an engineer for your analysts, but it's not even a problem that they have, and you just wasted all this time and effort automating something, and they're like, hey, that's great, but we're really hurting with this other thing and wish you'd solve that problem. So you want to make sure that you validate your requirements, just like any other project. And finally, of course, automation can create more problems. At the organization I'm currently working at recently, they just sent out a new automation that decided to make 3,000 incident tickets in a day based on a bad signal. So, like, you know, there's there's some fallout to be had here, and thus care and caution is recommended as you move forward in your automation journey. So what exactly are processes, workflows, and tasks? Essentially, processes are a series of actions which are repeated to meet an organizational goal. So it's something that your organization wants. In this case, security incident response is a business process which meets the organization's goal to ensure that the impact to the business is minor, as minor as possible when responding to security incidents. That's the purpose of the security incident response process, to meet that goal. A task is a particular goal that needs to be achieved in service of a process. So analysis is a very common task as part of security incident response. And finally, workflows are the ordered steps which are repeated in order to accomplish a task. So, for example, gathering all the relevant logs from various systems, collecting them into one place, filtering them down, say, for one particular IP address, and then analyzing that, that would be one workflow, right? That's the workflow for that part of the analysis. You need to complete that. So that's the buckets that we mean when we talk about these things. So there are a lot of different SOAR platforms. They vary from very specialized ones, such as the company KnowBe4, which focuses on email phishing and stuff like that. They have a SOAR platform called Fisher, and it is very much focused on phishing related stuff, but it is a SOAR platform in that it does all of the things that we're going to talk about SOAR platforms do. It's just highly focused on the email phishing portion. Also, of course, you have extremely generalized systems, such as Palo Alto's XSOAR, or Cortex XSOAR. That can cover basically any use case and get its claws, so to speak, into any part of your infrastructure and react to it, including interacting with, say, KnowBe4's Fisher. Like, it can be a meta platform that manages everything. Generally, these big SOAR platforms cost a lot of money, but there are some free plans available to try things out. And of course, there's a few open source options, which I'll take you through, that you can try so you can set up locally to kind of give a trial and say, hey, maybe this would benefit us. Here's us trying it out ourselves. The primary benefit to spending the hundreds of thousands or even millions of dollars that these SOAR tools will cost your organization is that they've already written and will continue to maintain all the Python and related code to, say, connect to all your various services, as well as they've already written automations for particular workflows, such as that log gathering workflow that I discussed. Palo Alto Cortex definitely has a built-in workflow to search your SIM for a given IP address. You know what I mean? Like, they just give you that as a template. You do it yourself for open source, you're gonna have to build all those things. You're gonna have to be the one putting the glue together. And in 6 months, when some API changes, you're gonna have to fix the connector. So that's the trade-off. And just making sure I got everything on that slide. Yep. All right, so I went through the Gartner report on the top SOAR tools, and these are some of the top rated in Gartner tools that I then reviewed their documentation to see what their Python support was like, and now I have rated them on their number of Pythons, which I will explain. So the aforementioned Cortex XSOAR is rated 5 Pythons, because it's used extensively throughout the platform, including for playbooks, content packs, integrations, and so much more. Basically, every part of Cortex has a custom Python integration possibility. You can literally do anything in it. So that is one of the most expensive, but also one of the most powerful tools. Next on the list, we have this Torque hyperautomation. Torque hyperautomation is a newer tool that I have not personally used, but they're pushing that whole hyperautomation concept that I mentioned. And they did not invent it. The definition that I gave you was from IBM from several years ago, so it is a thing. But in general, for their Python integrations, scripts can be in Python. They can also be JavaScript or Shell. Scripts can be inlined within an action, and they can also represent a callable part of a workflow. Also, as part of their hyperautomation, scripts can be generated automatically, and they can connect to basically any part of the business. Like, you basically can point and click and say, yep, I need this tool to talk to this tool and get this data, and it'll GPT it up to give you a Python integration to do that, and then you can, fix it up, customize, whatever you need to do. But that's their value proposition. The swim lane turbine, they allow for Python scripts that can be native actions. For example, a transform is a native action. So basically, data comes in, and you can map it to say, when this data comes in, run this Python script to transform the data, and then pass it off to something else. So it's fairly strong. Tines is another one that I have not used, but it is very highly rated. And it allows for Python scripts that are storyboard actions, and those actually run in isolated AWS Lambda environments. So basically, you only pay for what you use in terms of usage, and it's separated from both your and anyone else's infrastructure, which is both good and bad. Obviously, isolation is good, but it adds difficulties for integration. And then finally, surprising to me, because I don't personally have a lot of good experiences with FortiGate tooling, but apparently the FortiSOAR is very highly rated, but it's only one Python's, because when I looked at their documentation, the only way I could find to do custom Python code in it is with a code snippet connector that you then add into, you have to add this plugin called the code snippet connector to then create an action that uses that then it's just very Byzantine, I guess is the term. So I don't know if I recommend that one, but it's highly rated. Another concern to bring up is, incidentally, your SOAR platform and tools can become part of your overall attack surface. This is straight from the Torque hyperautomation documentation. So you can see they say, make sure you escape these JSON strings to prevent code injection attacks. So if someone knows that you're using this service and can happen to send the right JSON data to your edge thing that ingests stuff, and you don't use this JSON encoding or escaping function, they can arbitrarily execute code within your SOAR platform. So that's, something to be aware of. So in general, the old standard advice of be strict in what you output, lenient in what you accept, and never trust user input stands true when you're implementing your custom Python SOAR code. All right, so let's look at some of these open source tools. So Shuffle.io is the most advanced and complete service that I've seen. They have a hosted service that you can pay to use, but they also have a straight up GitHub that you can go to and download the source code and run the service yourself, self-hosted. Its Python support is very strong in that it allows you to upload a zip file of an application, which essentially is just a folder that has Python scripts and, importantly, data, right? You can basically put anything in here. And as we kind of mentioned, Python being the glue to other stuff, and if you think about it, ultimately, whether it's running on AWS Lambda or some virtual machine or whatever, when your Python function gets called, it's running on a machine somewhere. So you could even put executables in other languages like Go or Rust or whatever, and call those within your application. So essentially, Shuffle will let you do anything, is what I'm telling you. Also, that's all from them. Okay, sorry. StackStorm is it's not a specifically SOAR platform, it's a more general automation system that can connect any kind of application, service, and workflow. The Python support within it is there are action runners, and you can just say, hey, for this action, run this Python code. Additionally, they have a Python CLI to manage the StackStorm cluster, and an API library so that you can essentially use it as like a awesome task runner to pull from other systems. Maybe you can have it as your own special side system if your company won't push for XOR or one of the big ones. You could build this out on a little AWS VM or something and at least have something going, right? The next one, Catalyst there, it allows any arbitrary automation running in a Docker container, and it's got a nice little template to set up Python containers. So essentially you map this workflow has these actions, and action is a Docker container that runs XYZ. So that's pretty cool, nice and flexible. TraceCat is a newer one that says it explicitly wants to replicate tines or even XOR, but those are huge differences in functionality. However, currently, as of last month, their custom Python integrations are a work in progress and only in the alpha version. So they're not there yet, but it's one to maybe look out for. And then finally, Velociraptor. I don't know if any of you guys have heard of this, but it's not technically a SOAR tool per se. They call themselves an endpoint management and digital forensics and incident response platform. But it does have an API, which can be used from a Python script, essentially. As mentioned, any API can be used from a Python script. So what's cool about Velociraptor is it'll run an agent on your endpoints, monitor stuff there, and then from the central Velociraptor system, you can send out queries and commands out to the endpoints. And that's how it works. It's unlike a SIEM. It doesn't send all the logs anywhere to any point. It sends commands out to be distributed to the endpoints and then sends back the results. So it's good for ad hoc stuff, basically. Obviously, if you're in a big enterprise organization, you just have actual dedicated endpoint protection and an actual SIEM. But if you're a startup or a hobbyist or something like that, check out Velociraptor. It's pretty cool. All right, so this, don't worry about how well you can see it. I'm going to explain the important parts, but I'm just trying to give you a sense of the complexity involved in a SOAR platform. This is the reference architecture diagram for StackStorm, which was one of the open source tools that we talked about that you can run yourself. And so it shows the general important components of a SOAR system. Generally, you're going to need some way to coordinate between everything, so everything's focused on a central queue and then some kind of container or VM system to run stuff. At the bottom here, I got to pull the notes here. Yeah. So at the bottom here, right in this area, in that area, we can see the main parts involved are things like the scheduler, the timer engine, the rules engine, the workflow engine, and action runners. And they all talk to databases, caches, and of course the central queue. So the idea is that SOAR operations in general can be executed manually by an operator to run an action, or the system can, in response to some event via the rules engine, run an action, or on a scheduled basis, you can run an action. So that's generally how SOAR platforms work. That's how they respond to things. You either manually have an analyst say, hey, I need to run this workflow. Off it goes. Or you say, hey, when a log comes in that looks like this, I want you to run this workflow. Or you say, hey, every day at midnight, run this workflow. That's how it works no matter what SOAR tool you use. All right, so some of the processes and workflows that are used in SOAR will generally be mostly around security incident response, threat hunting, and security validation. Possible workflows will generally include things like the creation and management of tickets, the gathering and processing of threat intelligence, blocking and unblocking potential indicators of compromise, or even investigating potential indicators of compromise and then doing other stuff. You know, as complicated as you want to make the workflow, you can. Oh, cool, I'm doing really good on time. I was supposed to vamp if I wasn't at 20 minutes, and I am. All right, so what do I mean by local first SOAR? My general premise here is that the SOAR process can and often will start with an individual analyst or engineer having some problem that is upsetting them and causing them pain, and they need to solve it. So they write a Python script locally on their machine and solve it. And as I've mentioned and shown you, every SOAR platform pretty much allows you some way to give it a custom Python script. So if you write a custom Python script and it is useful to you and makes your job better and more repeatable and faster, it'll probably do the same for the rest of your team. And then you should move through the process of, cool, now I've validated that this is a useful automation, let's move it into our central SOAR system. And that is my general workflow for trying to do SOAR at all, period. It's especially a problem in the common place that many people are where your organization doesn't have tools such as a SOAR. If you don't even have a SOAR, what are you supposed to do? Write a Python script locally. Most of your services have API keys for your logins, and they're generally turned on. Maybe your organization turned them off, but you probably know the right people to ask to say, hey, can you enable for my account the ability to use an API key? Because it will make everyone's job better. That's your justification. All right, so essentially, just wanted a cute little picture of a snake here to, you know, put home local first, knit your hat, put it on. All right, so let's go through an example. Automating the removal of entities. At a previous job I was at, we were changing endpoint protection services, and the company we were leaving said, oh, that sucks, we hate you and want to charge you a ton of money, so these non-deleted but marked as terminated devices in the portal are all going to be billed to you as full devices unless you remove them before 2 days from now. Oh, and by the way, our interface only allows you to remove 10 at a time. And so we had one guy sitting there removing 10 at a time, and he spent like 4 hours one day, and I was like, bro, what are you doing? And he told me, and I said, don't worry, I got you. And I wrote a Python script to query their API, which even in the API only allowed 10 things to be removed at once. So I had to make a loop that literally went through everything 10 at a time, sending API requests. But you know what? We deleted all those devices, and they thought they were sticking it to us, but we used Python to SOAR out of it. So another example is you've got the same IOCs, and you want to send them to all the OTs. For those not aware of the corporate lingo, OT is operational tools, and IOCs is indicators of compromise. So typically you'll get, for example, an IP address, which represents some bad actor, like this is where people are hacking ransomware out of. So you'll want to block that. but you might have multiple different services that you need to block it at. You'll need to block it at the network level for all your switches. You'll need to block it at the network level for all your cloud services, right? So you might have like 2 or 10 or 20 different services that you have to send the same IP address to get blocked. This is a great opportunity for SOAR because Python will let you write a script that says, okay, give me this IP address and I will create a block in these services. And that's essentially what I have done in the past many times for many different purposes. Another nicety, which you can then add on to that, and which XSOAR, for example, I have seen has stuff built into it, is you can then add IOC lifecycle management into it. Because just adding an IOC into your block list is only half of the problem. Eventually, your network team will start telling you, no, we will not add these 1,000 IP addresses because we already have 10,000 IP addresses in the block list and it's slowing down our switches. So with the automation involved in SOAR tooling, you can send this stuff to a database where you log when that IOC was added, and then with the scheduled process, you can go through and remove IOCs older than X number of days, and now your network team never bitches about you adding IOCs because you're constantly removing the ones you don't need anymore. So another example would be processing various outputs from other systems, so to speak. So one that I kind of alluded to earlier and performed recently is the SIM that the company I'm working with uses will upload a CSV to a ticket with rows that match, the IPs or whatever that it found in the initial ticket creation. However, it has highly enriched data. So that gives me a CSV with literally 500 columns. I can't, as a human, go through an even one line CSV that has 500 columns and tell you what it means. But I can spend a couple days or a few hours or whatever taking it apart, figuring out what columns actually matter, and then writing a Python script that says, oh, a ticket has been created, a CSV has been uploaded, I have now processed and interpreted it and said, boop, yep, there are 5 unique IPs in this and 3 different actions. It's happened at these times of days, just basically pulling out the actual information that you as a human need and then putting it where it needs to go. Again, that started with the whole local first process of I needed to do this for a single investigation. So I wrote a Python script that I ran locally on my machine to process that stuff. But then after doing it for a few tickets and getting it solidified, and people started noticing my tickets were much more readable because other people were literally just pasting a subset of, say, 30 columns and just pasting it in and being like, here's the evidence. Whereas mine was coming out with prose saying, yes, we have found blah, 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 but I didn't write any of it. The script output it, you know what I mean? So eventually people were like, wait, why are yours so much better and faster? Because I wrote code to do it. Can we do that for everyone else? Well, you've got a SOAR tool, so yes. If you don't have a SOAR tool, like I said, that's when you start looking into maybe some little shadow IT and build yourself a stack storm or whatever. So that is generally the idea, generally where we're going for. I don't know if there's any questions that people have, but just like a large language model, I can generate responses that sound pretty reasonable. And if you do have any questions, please shout them out. All at once is great for enthusiasm, but one at a time is better. It's okay, I came prepared. Because I did prepare some sample questions, just in case. So, how would we apply SOAR to forensics? Oh, sorry.
I was waiting for everybody else. So people send mission requests. What's like your go-to toolkit? Like not every problem is the same, right? But what are your like go-to toolkit or libraries for the bulk challenges we solve?
So the question was generally what are the go-to Python libraries and such that I use for solving general challenges. And so yeah, those three that I mentioned, Request, Beautiful Soup, and Pandas, they're I should go time, yes. Let me repeat all of that. So the question was, what generally are the Python libraries and tools that are my go-to for solving any problem without knowing ahead of time, what am I grabbing in my tool bag? So those three libraries that I already mentioned, Requests, Beautiful Soup, and Pandas are definitely in there. I'm also a big fan of this library called Tools with a Z, which does various lazy data manipulation. And there's just literally very specific situational things. Like if I'm pulling through XML data, I'm going to probably want some kind of XML parser, which again could be Beautiful Soup, but maybe I need something that's faster. So maybe I'll use oh man, I don't even remember the name of that one. But anyway, there are a ton of useful Python libraries. I stick to those probably 3 or 4 just to start out and then branch out specifically based on the problem. Yes, sir.
You mentioned automation and breaking. Are you going to talk about that more, or do you have specific examples?
Automation of what?
It's automation just breaking.
Good question. So yeah, no, I didn't have much planned to talk more about that, so this is definitely a good time. What? Yes, I'm gonna. So the question is, what exactly happens? What does it look like when an automation breaks? So generally, especially if you're using a third-party service, threat intelligence, for example, is a pretty common one where you might want to, say, read articles from Bleeping Computer. And so therefore, you might use Requests in Beautiful Soup to pull article data from Bleeping Computer. But they might decide, you know what? We've decided to redesign the website, so now there's a new ID for this main div, and here's some other extra stuff that you don't need that's going to trip up your automation. So you're just, enjoying your day, and then you get a notification from the threat intel team that suddenly all their Bleeping Computer reports are empty, and you might have to go figure out why. So again, that's one of the kind of benefits of using, say, an XSOR over doing it yourself, is you get to go to them and say, hey, my automation broke, fix it. Otherwise, you then have to go through and essentially redo the work of figuring out, okay, what is the exact div that I need to access to get this data. Does that answer your question? Awesome. Thank you. All right. So how could we apply SOAR to forensics? So for this kind of workflow, I've built some stuff that's essentially like, okay, we have a machine that has been exploited and we need to know what's happened. So we have uploaded the disk image to this location in S3. That causes a rule to fire saying, hey, this bucket with forensics images has received a new file. I will now spin up a VM large enough to hold that image, push the image up to it, and then process a timeline from the hard drive, and then output that timeline back to S3 so that an analyst can then read it. You could then, of course, further build onto that to have other automations that then ingest the output of the timeline to then do some of that summarization that I was talking about in the other automation. So essentially, any kind of repetitive process that you're doing in your day-to-day security operations can potentially be automated via SOAR. You just have to map out what is the process, what are the workflows, What are my actual steps, and which of these steps can be automated? And again, for me, the most important thing is to start with the most painful thing. For me, the reason why I would have made such a forensics automation thing like that is because the most annoying thing is to repeatedly set up a new fresh forensics VM, copy the data to it, start the same command line to analyze the disk and output a CSV. That's potentially an hour plus of work every time. And once you automate it, it's more like you get a notification after it's done, which is it's just so much less painful. And that's what we're all about here. So how do I convince my organization? Again, you want to analyze those processes and workflows. You want to rate them on time consumed and painfulness. And it should become quickly apparent that removing some of the pain will save you lots of time and probably money. And of course, it'll make everyone's lives better. To convince those accountants, you need to remind them that responding slowly or incorrectly to a security incident can cost exponentially more money. And so therefore, every amount of time saved, an extra bit of reliability equals not spending more money on security. And to really bring it home, you can make a nice little matrix of various risks to your organization and the costs of those incidents occurring, which always look very scary because they are. For most businesses, to have, say, a ransomware attack take out your production, your production, and not have anything happening, that could be hundreds of dollars, hundreds of thousands of dollars, millions of dollars per hour that your company is losing. So when they see that and you say, look, we just need to spend $2 million a year on XSOAR and invest in a couple developers, and that will not happen to us, they might be a bit more willing. So I just want to ask one final question, which is, did you guys get any new ideas? I'm hoping so. And we'll somewhat summarize a little bit here. Once again, we're looking to improve our lives by removing the pain, creating automations to do those repetitive actions for us and do them efficiently and quickly, saving us both time, effort, and money. Generally, we want to do those things local first, solve your own problems, solve them for yourself, and then expand to the rest of the organization, make it pretty, make it nice, make it, generalized. But you should always look to solving your own pain first, and then solve the pain of the others around you. And eventually, if you keep iterating on that, things will be a lot more painless in your job. The main pain will be focusing on the automation, which again, I much prefer that. I would rather wrestle with Python and some obscure library issue than have to click the same 5 buttons for the 1500th time and miss one and then get in trouble because I missed something. So that's kind of my general feeling on it all. So thanks for listening to me ramble on about Python for security orchestration, automation, and response. And here's a cute snack, so I can hopefully inspire you on your soaring with Python. Nice. All right, thank you all very much.